Understanding clients and servers is vital in Roblox development, so let's begin. Each Roblox game has a list of servers, with each server containing a group of players. The server is essentially a computer that handles all player connections. For example, when players interact with each other, this information is passed through the server before being sent to other players. When writing scripts, we can choose whether a script runs on the server or on individual players' devices, which we call clients. From now, we will start referring to the scripts that we have been using as a server script. The server script can execute code from the workspace or server script service, and will run code on the game server rather than on players' devices. If something is executed in a server script, such as making a part transparent, there will be a small delay before players see that change. This is because the information needs to be handed to each client over the internet, which takes time to send due to latency. This is where LocalScripts come in. When a player joins a game server, their character model is automatically added to the workspace, and a new player instance is added to the player's service. While adding the player, the server clones all instances from these starter folders into the player's folders. For example, GUIs are copied from the starter GUI into that player's player GUI. Additionally, the contents of the starter pack are copied into the player's backpack, starter character scripts into the player's character, and starter player script into the player's player scripts. A local script is a type of script that runs directly on players' devices. So, if we add a local script to the starter player scripts, it will appear in each player's player scripts upon joining and run on their devices. Changes made through the local script happen immediately for the player as they're ran, as everything takes place on their device and nothing needs to be transferred across a network. As a result, local scripts are for handling things that affect the individual players and need instant responses, such as detecting player input and displaying information to that specific player. On the other hand, server scripts are generally used to handle game logic, store player data, create parts, or anything that applies to all connected players simultaneously. Now, anything visible to a client can actually be fully accessed and modified by cheaters, including local scripts. They can also make and run their own local scripts from their client, even if you haven't added any yourself. So, to prevent cheating, Roblox prevents code written in local scripts from having any effect on the server or other players. Otherwise, cheaters would be able to cause havoc, as the effect of any code they write would be seen by other players, which was actually the case until 2018. Scripts running on the server can't be accessed or modified by cheaters, so they're safe to run code that would be dangerous to give cheaters access to, such as saving player data. This is why Roblox limits accessing certain functionality to server scripts only. For example, player data can only be saved from a server script, meaning cheaters can't modify it. However, clients and servers can safely communicate with each other, which is what we will talk about in the next episode. To experiment with client and server connections, feel free to go to test and then create a server for 2 players. You'll be able to see the perspective of the game server as well as the perspective of 2 connected players. For example, if you change the transparency of a part as one player, the change will only be visible to that player. You'll also see that players can't access the children of the server storage or server script service, but have full access to view the children of the workspace. This is because the server storage and server script service aren't replicated to clients, meaning anything stored there can't be accessed by clients. Be sure to play around with this before continuing. Now finally, the other script type that we can use is a ModuleScript. ModuleScripts can be stored anywhere in a game and are very similar to functions, as they don't run until required by another script. They're used by developers to split code segments into separate scripts, making them easier to navigate. ModuleScripts can run any code but must return a single value of any data type. For example, this ModuleScript declares a table containing functions and variables, and then returns the table just like a function would. In a server script or local script, we can then call the require function and pass the ModuleScript instance as an argument. Just like calling a function, the require function runs the code in our ModuleScript and then gives back the returned information. Our variable is now assigned to the table that the ModuleScript returned, so we can call the functions in the table from our main script. We can also just return a function directly and call it like this, or any other data type. For example, this table stores a list of admin usernames which we can access like this. Or this string contains a top secret password which we can access like this. ModuleScripts run as extensions to existing scripts, so a ModuleScript required by a local script is run on the client, or on the server when required by a server script. Additionally, ModuleScripts must be placed somewhere that your script can access them. To run them from a server script, you might place them in one of these places, or from one of these if you're running them from a local script. If you want a ModuleScript that can be accessed by both server scripts and local scripts, you can store them in replicated storage, which stores instances that can be accessed by both the server and clients. And that's it. Don't forget to practice and then check out the next episode when you're ready.